Assalamualaikum. Hi guys. In this video, I'm going to focus about the next subtopic 4.4 Intermolecular Forces. The learning outcomes for this one, we are going to learn how to describe the intermolecular forces. There are two types of them, van der Waals forces and hydrogen bonding. And you have to explain the factors that influence the van der Waals forces and hydrogen bond. We are going to focus about intermolecular forces first, IMF, for van der Waals forces. So what is intermolecular forces? Intermolecular forces, the short form is IMF, are the attractive forces between molecules. IMF are very much weaker than covalent and ionic bonding. And the strength of IMF can be determined based on the physical properties of the substances. For example, melting point, solubility, boiling point. So that is the physical properties. So when you talk about IMF, I mentioned about the attractive forces between molecules. For example, we have two HCl molecules. So where is the position of intermolecular forces? This is it. Okay, so the attractive forces between Cl from the first HCl molecule with hydrogen from the second HCl molecule. And for the covalent bond, you can see that the attractive forces between H atom and Cl atom in the same molecule. Ataupun dalam erti kata lain, ini adalah intramolecular forces. But we don't even discuss about that one because it's not really significant. So we are going to discuss about IMF between molecules only. For your information, there are two types of attractive forces between neutral molecules. The first one is van der Waals forces, dan pastikan awak tulis spelling dia betul-betul tahu. Dia punya V kat sini adalah small letter, bukan capital letter. Capital letter hanya untuk W here. And then for van der Waals forces, there are two of them, dipole-dipole interaction, ataupun we call it another name, permanent dipole. And the next one is London forces. The second intermolecular forces is hydrogen bonding. Please make sure you are not confusing with chemical bonding, iaitu ionic bonding ataupun covalent bonding. There are totally different things. So for intermolecular forces, because of we know there are three of them that we are going to discuss later on, that is why we need to know the strength of the following intermolecular forces. When we talk about the strength, the most strongest is hydrogen bonding, and the weakest one is London dispersion forces. Let's talk about the first van der Waals forces, which is dipole-dipole interaction. Dipole-dipole interaction exists between neutral polar molecule. In the previous video, you've learned already about polarity. So I hope you can understand how to determine the molecule whether it is a polar molecule or not. So for dipole-dipole forces, how it happen? It form when you have the first HCl molecule and the second HCl molecule. You can see from here and here, there is a partial charge between them, and the attractive forces will pull or will attract different charges due to their different electronegativity between two same molecules. This is where the dipole-dipole forces form. So the strength of dipole-dipole forces depends on the size dipole moment of the molecule. If the dipole moment is higher or the more polar the molecule, it means that the strength of dipole-dipole attraction is much more greater. So, maknanya you kena tahu how to determine the polarity of a molecule. Next one, we will talk about the second van der Waals forces, iaitu London dispersion forces. The other name is London forces ataupun dispersion forces. Mana-mana pun tak apa. And for these forces, we have to know a big story how these London forces form. London forces exist in all atoms and molecules. Let's say we take non-polar molecules. Non-polar molecules do not seem to have any basis for attractive interaction. However, an atom has positively charged protons in the middle of the proton in the nucleus, and negatively charged electrons surrounding the nucleus. So on average, we should know that this is how the sea of electrons looks like in one atom, and in the middle of it we have proton with positive charge. So we can understand that the negative charge of electrons in the atom is spread evenly around the nucleus. And then the story continues. At any instant, one side of the molecule will have higher electron density than the other side. So you can understand there is partial positive and partial negative. So maknanya banyak elektron akan ke arah partial negative charge. At this instant, the atom or molecule become a small instantaneous dipole. Maknanya dia berlaku dengan sekelip mata. Then induce a dipole on the neighboring atom and molecule. So this is the atom that we talk about just now. And then bila dia jadi small instantaneous dipole, dia akan menarik another neighboring atom ataupun molecule untuk dekat kepada dia. So bila dekat kepada dia, kita akan nampak ada electron repulsion, di mana electron repulsion ini akan menarik. That is why a temporary dipole on one atom can induce similar dipole on neighboring atom so that they can attract one another. So daripada dia spread evenly for the electrons around the nucleus for this new neighboring molecule, sekarang dia sudah ada similar dipole yang telah induce daripada atom yang sebelum ni. So inilah macam mana London Dispersion Forces happen. Dia hanya berlaku sekelip mata sahaja. Next, the exact magnitude of dispersion forces depends on polarizability of the atom. So polarizability ni apa? Sebenarnya dia adalah satu proses di mana electron distribution in the atom or molecule can be distorted by a nearby electric field. So dia akan bergantung kepada number of electrons dan electron cloud. Sekiranya you have a greater number of electrons or more diffuse electron cloud for a certain atom, it means that polarizability will increase. Dispersion forces biasanya akan increase with molar mass because bila molar mass untuk certain molecule tu besar, maknanya dia akan ada more number of electrons, hence larger the orbitals. That is why dia akan ada larger momentarily distortion, iaitu polarizability. Therefore, dispersion forces akan bertambah. So you talk about already two types of van der Waals forces, iaitu the first one dipole-dipole interaction dan yang kedua adalah London dispersion forces. Now I'm going to introduce how you want to determine the force for that molecule. Yang pertama, step pertama kita kena tentukan molekul tu sama ada dia polar ataupun tidak sahaja. Sekiranya dia tidak polar, automatically that molecule will contain only London dispersion forces. But if the molecule is a polar molecule, we are going to continue whether it has H atom bonded to N or O or F atom. Kalau yes, it can form hydrogen bonding. If it's no, it can only form dipole-dipole forces. So ini adalah tips di mana saya nak ajar awak how to identify the intermolecular forces. Let's try example 1. You have HCl. So, first thing first, you have to draw the Lewis structure for this molecule. Ataupun lebih tepat lagi, nak nampak dengan lebih jelas, try to draw the molecular geometry. So, we have HCl. HCl, the drawing should be like this one. So, you can see that HCl is a polar molecule. Why? Because you have partial positive on hydrogen and partial negative on chlorine. So this is polar molecule. So bila dia polar molecule, maknanya apa intermolecular forces yang wujud dalam this molecule? Kita ada dipole-dipole interactions. And then lagi satu, dia juga ada London forces. Why? Because London forces can exist in all atoms and all molecules. Next, we go for oxygen. So how the oxygen molecules looks like? It should be like this. So from here, you can see that two atoms bonded together with double bond in the middle of them. So you can see that these two oxygen atoms have the same or similar electronegativity. So there is not much difference for that electronegativity. We can conclude that O2 is a non-polar molecule because this covalent bond is non-polar bond. So sekiranya non-polar molecule, maknanya hanya ada satu sahaja intermolecular forces yang wujud, iaitu London forces. Next, we go for SO2. So how the molecular geometry for SO2? It should be in band shape or V shape. So if you look right now, sulfur is more electropositive than oxygen. So you can see that S double bond O bond is non-polar molecule. That is why you can determine the direction of dipole moment towards oxygen. So awak akan dapat like this one. So dia akan menuju ke arah oksigen. So bila dia bertumpu ke arah bawah, so dia akan ada resultant dipole moment going down. So this is resultant dipole moment. Bila kita ada resultant dipole moment towards one direction only, we can conclude that mu is not equals to 0. So bila dia tak equals to 0, hence SO2 is a polar molecule. So bila dia polar molecule, kita boleh identify sekarang intermolecular forces yang wujud adalah dipole-dipole forces dan juga London forces. Next, we go for example 4, di mana kita ada CO2. So the molecular geometry for CO2 is like this. So it is in linear shape, and then the direction of dipole moment is supposed to go towards oxygen, opposite side to one another. So kita boleh conclude right now, mu is equals to 0. So when mu equals to 0, CO2 is a non-polar molecule. Hence, the intermolecular forces exist in CO2 only London forces. So now, when you've already know how to identify what type of intermolecular forces exist in certain molecule, you should understand as well the factors affecting the strength of van der Waals forces, and this one is in order of priority. Kita kena follow ikut priority. The most priority one is molecular size, followed by molecular shape, and the last one molecular polarity. So for molecular size, if we got the higher molar mass, it means that the number of electron increases. Hence, the atomic radius also increases. So bila dia ada banyak electrons, maknanya ada bigger possible temporary dipoles, therefore bigger dispersion forces ataupun bigger London forces. Hence, we can conclude that the larger the size of the molecule, it means that the outer electron are less tightly held by the nuclei. So the electron distribution is more easily disturbed sebab interaction dia sangat lemah. For example, saya ada London forces. So London forces, boiling point akan makin meningkat when going down the group for noble gas. You can see that from negative 269 degrees Celsius, it increases until negative 62 degrees Celsius. This is because of the number of electrons increase, resulting greater atomic radius. Kalau kita going down the group kan bentuk segitiga, so size dia punya atomic radius makin besar. So bila atomic size dia makin besar, maknanya electrons akan boleh bergerak dalam ruang yang lebih besar, which resulting greater polarizability. Therefore, the strength of London forces increases. Bila dia increase, attractive forces to increase, kita perlukan more energy to overcome these forces. Therefore, greater boiling point. Untuk molecular size for London forces dan juga dipole-dipole forces, you can see from these examples, we got three different compounds, HCl, HBr and Hi. Ketiga-tiga ni adalah polar molecules, di mana bila polar molecules, dia ada dua-dua, London forces dan dipole-dipole forces. Although HCl is more polar, you can see the polarity is 1.0 compared to HBr dan Hi. However, it has the lower boiling point due to the smaller molecular size compared to HBr dan Hi. So that is why molecular size adalah the top priority untuk tentukan strength of van der Waals forces. Next, for molecular shape, macam mana molecular shape ni boleh berlaku untuk menentukan strength of IMF. Kita akan lihat, contoh kita ada linear molecule, surface area dia lagi banyak dan besar berbanding dengan branch molecule. So surface area yang saya maksudkan ni adalah surface area in contact yang warna purple ni. So kita boleh nampak lah bila shape dia linear, dia akan ada bigger total surface area of contact. What's the rationality about this part? Kita take one example here. We got butane and 2-methyl propane. Kedua-duanya mempunyai same molecular formula, iaitu C4H10. Tapi shape dia je yang berbeza. This one butane is linear, 2-methyl propane is branch. So when molecule have similar size, the shape can be the second factor untuk determine the strength of van der Waals forces. Long and linear molecule allows greater contact of area, then gives rise to greater London forces because the area is larger. Therefore, butane has greater boiling point compared to 2-methyl propane. Next one, we go for the last factor, iaitu molecular polarity. We got example boiling point for CH3F dan juga CH3CH3. So, ini adalah non-polar molecules for ethane dan this one adalah polar molecules for fluoromethane. If you take a look here, we look at the polarity. So, intermolecular forces in polar molecule is stronger than non-polar molecule. Therefore, boiling point dia akan tinggi because we need more energy to overcome the attractive forces. So, inilah kepentingan kita belajar tentang van der Waals forces. We have to know how to describe the intermolecular forces ataupun attractive forces dalam certain molecule. I know there are a lot of facts right now starting at this point, this video, but you can try to do a lot more practices based on tutorial questions so that you can understand about this concept. So that's it for now. I will see you in the next video. Bye!